So, so Kentu, what it is? It's a company based in France, in Grenoble. So we are an OSGi participant member. We are Eclipse and Synapse supporter. And we do digital twin solutions for smart cities. So the usual thing, you already saw me last year, if you were there. About me, so I'm the software architect at Kentu. I'm also an Eclipse committer. I'm also the writer of iPopo, the Python version-ish of OSGi. And yeah, you might know me from that. So today we'll speak about multiple projects we're working on at Kentu. The first one will be the COGNIFOG project. So it's an EU project about having a continuous deployment from the cloud to the edge and to the far edge using Kubernetes. So as you can see, we have a lot of friendly companies for that project. And the first thing we'll see is how it's supposed to work. So we have a modeling of application, then the operation part of pushing Docker images to the far edge, and then the runtime components that go at the different levels. So different levels, meaning so cloud, obviously you know what is a cloud now. Edge, it goes from, like you see, computers, phones, and possibly gateways. So not large servers, but mostly like ARM-based gateways. And then the thing level, you have smartwatches, you have factory robots, and cameras, etc., etc. So we work all the way in. And us at Kentu, so we are both on the modeling part, the runtime both in the cloud, and we do the link between the things and the edge. So the first use case is in Greece. It's about health and safety in construction sites. So that one is about a big project in Greece to construct windmills. So they have a lot of people in a large area, and due to that, they need to have some health and safety insurances, like, for example, having some medical people, medical staff around in case something goes wrong. And what they want to do is to have wearable devices, mostly smartwatches, on every worker, and to have the medical staff having some kind of a station. So it looks like that. It's a big station that receive everything from the smartwatches. The idea here is to avoid being dependent on the cloud. So there is a lot of Wi-Fi repeaters everywhere on the construction site, and you have one gateway at the construction site. The medical staff look at that. If there is an issue, it can go where the worker is. And if the cloud is available, you also have some telemedicine service, which means if something doesn't look right, a doctor from a hospital or for the company medical staff at their HQ can interact. So in that one, so as you can see, you have a cloud part. Like I said, everything here is optional. And we have an auto detection of if it works or not. Obviously, you cannot bootstrap everything if you don't have the cloud, because the definition of the composition of services will be done by the cloud, pushed to the station, then pushed to the smartwatch for the app that will run on it. And for everything, so they are using Kubernetes with the K3s version. Yeah, and so that's supposed to work. So currently we have a construction site that is used as test, and we're happy with that for now. And here for Kentu, we are just on the cloud side, but we are trying to move down to the station side, as it's important for the on-site medical staff to have some information right away on the screen, on a usable way. The one I like the most is that one, the coordinated crisis management. So that one is from Thales, and it's the idea is to prepare for the next big flood in Paris. It's one big flood every century, and the last one is from 1910. So we're a bit late. So yeah, so that picture was taken from the Gare de Lyon, so around here, and you see all the flood that came at that time. So it's a modern map with the flood at that time. So it would be even worse today with the subways, etc. So how do we do to work in those conditions? Knowing that if we have floods like that in Paris, there is a lot of chances we won't have fiber optics, we will lose a lot of connectivity. So that's why Thales decided to have something at the fireman station level. So that's why it's not a cloud, it's a headquarter here. The idea is to have an on-site network level. So here, for example, it's Orange that is working with us to provide 5G on-site. So really a private 5G network. So that everybody from the fire stations and medical stations can communicate. The stations will be will host a manager that will manage a single neighborhood, and they will have mobile units, and themselves can have different tools. So, for example, drones and a live video feed coming from the drone to the fire truck, and if available, to the fire station, so that everybody has a management that works. On our side here, what we'll show, I will show you the dashboard afterwards, but what we will use as incoming data is mostly sensors, so water level sensors to know where the floods are, but also we will have gyroscopic sensors on buildings to know how a building reacts to the flood, to know if it's safe to enter it or if it's necessary to evacuate people from here. And so here in Kentu, we are working in the headquarter place, the stations, but we are also coming to the fire truck section. The idea here is to have a way for everybody, both the fire station and the fire truck, to see what they need to see. Also, final thing, the drones are able to drop new sensors so they know their location. They can drop a new sensor if necessary, if the place is not available by a truck. So the other part where OSGi can be good for your health is smart intersections. So we first worked with the Fed Intersect project. It was in New York City. So for the left side, and Santander for the right side. So the idea here is to use existing cameras and analyze them and to detect if there is a potential collision between a vehicle and a pedestrian. So that's the first thing we tried with that project. But we also have to avoid anonymity problems. So the idea was to have a camera that is filming the intersection, doing the object detection right at the level of the camera, and just sending us the bounding boxes and possibly the shape of the object, so that we know, for example, so here we know where the pedestrians are, but it's also important to know if a car is turning or not. So you can detect that with the evolution of the bounding box size, because as your car rotates, the bounding box increases in size. So that's the main purpose of that project. On the other side, the Fair Intersect also was the opportunity to publish some papers on what we do. And here you see the bounding boxes I was talking about. And for example, here, it was a funny situation because the red box here was in fact a construction machine because the road was under work. And so that's what our dashboard looks like a bit. I'll show you a bit more afterwards. But after Fed Intersect, we moved to the AI for Life project. So that one is with Helsinki and Istanbul. And that one is health in the real sense, let's say. So the idea is to reduce traffic congestion as it's a big issue for pollution and health for the people living there. And so that one, what we do is, I think if you know Google Maps or TomTom, you already know how it works. It's we have statistics on how many cars are on the road and how many stops they do, or how long they take to go from point A to point B. And we also have statistics on which way out a car takes to in a roundabout. So why is it important? It's just to know if we have to do a shortcut. So we have that a lot in France. I haven't seen it here. So the fact that you have a roundabout plus a straight way in the middle with traffic lights if necessary. So here we care a bit less of the anonymity issues. So we can have access directly to the video feed, and that helps us to have more information to detect really well what a car is supposed to do. And one of the funny things is that I looked at that camera, I think, 3 times, and each time there were a near-miss accident. So it's a really bad intersection. And on Helsinki, so the previous slides were about Istanbul. This one is on Helsinki. So here we don't have cameras, we only have radars. And so we have different levels of quality of data. So the closer to the radar, the better we are. And also we have to take care of tramways, because you have tram lines that are going between the driving lanes. So now that I presented you all of that, you might ask, why do I present that in an OSGi talk? So how does it work behind the scenes? So for us at CanQ, we provide a stacked solution. So the CanQI is the UI part, so the dashboard I showed you before. And that's where you have everything. So you will have the alerts, notifications of risk of accident. That's where the AI part is managed, but it's in fact executed in another part of the stack. So that part is obviously written mostly in Python, because that's the language of AI. But the rest, CanQI and CanQ Data Hub, that I will present you just after, are full OSGi. So the idea of the Data Hub is to ease the deployment of, in fact, what is underneath, an Eclipse and Synact instance, with a lot more providers for having access to specific protocols. So here is, for example, what it looks like for the CanQI. Here it's an energy management for a small town in the south of France, and to understand why they have some abnormal consumptions during the night. So we are looking at that. Here, for example, you have the map. So it's a live map of the buses and public transport in general in Helsinki. That's something we can have. And so we can combine that with information of traffic. So we can know where there are some places that are that can be optimized or not. We also have the location of bicycle stations. So if you want to rent a bike, etc., we can see if the station is placed correctly according to the use of people around, and depending, for example, on the historical sites, touristic sites, etc., that are around. So we can help cities with that. Here, for example, on the so on that side, we already saw the intersection things for AI for Life. On the left side and center, it's what we use for COGNIFOG for the construction site part. So on the left, you have a building with the two gateways, and in the center, you have, for example, here the smartwatches of people working on a terrain. And as you can see, we have the usual information. Obviously, the steps had a bit of parsing error, but yeah, that's the idea. Here is the project page. So when a city wants to do some optimization, here, for example, for an intersection, we can provide them with a nice page to see that they are going the right way or not. And here are the links, how it works underneath. So like everything we saw here comes from the web browser going to the eye. And the eye, in fact, aggregates data from multiple instances of SentinAct or Kentu Data Hub and calls the analytics just to, well, to do analytics, the basic stuff. And what is a data hub? So in fact, data hub, like I said, it's an Eclipse SentinAct with specific providers that we add, so additional bundles to manage the different protocols, either public protocols, open ones, or private protocols. So we have some projects where we have to do some neat reverse engineering to understand how that works. We also have a specific start script because we wanted to ease the life of the users, but also our lives, starting that thing. And in fact, what it does is just giving hand to the feature launcher that Tim will present you later today. And so SentinAct, it's something that comes from the CEA Institute in France. It was started 10 years ago. And it was open sourced and pushed to the, well, provided to the Eclipse Foundation in 2017. And since 2020, we are working to have it a bit better. So there was a complete rewrite in 2022 because it was coming from a research environment and they had some ways to do things, like doing reflection to call some basic functions. So it was a mess to debug, etc. So we increased that. Now it's readable and it's quite nice. And so what it is internally, in fact, it's using EMF, so the Eclipse Modeling Framework, to describe the different things you have in the real world. So you can use, so you can ignore totally EMF if you want. You can just say, I have a thing, so what we call a service provider. We have a thing that has a temperature sensor, this kind of stuff, and just say, I have a temperature sensor in that provider, and the EMF model will be in fact generated dynamically. On the other hand, you can prepare your EMF model for a kind of sensor, for example, the water sensor, so that you can provide additional metadata. For example, you know the unit of measurement or the calibration level, or indicate many other stuff. You can, I think, even have one model per instance if you want to add fixed data like the location in a specific building. So yeah. And the advantage of using EMF is that everything is typed. So you won't have the issues we know in Python side, which mean having a temperature sensor that is either an integer, a float, or sometimes a string. So here we know what it is, and I think it's OSGi converter that is used underneath if we need to convert.
Partly OSGi converter, partly EMF comes with its own converters.
Yeah, right. Yeah. And so, like I said, SentinAct, so it's a pure OSGi thing. So we have the SentinAct core that is really the bare minimum, which in fact starts up the EMF backend and prepare the basic services to add additional stuff. And then you add your own softbound providers or northbound providers to either access a specific set of devices. And the northbound provider helps provide what you loaded in Sensinact in different ways. For example, last year I presented the implementation we did for an OGC sensor thing access bridge, which is a specific standard for mostly geographic data, etc. So a lot of software work with it. So the usual way to access Sensinact is via the REST endpoint, basic REST interface. But it's really easy to add your own ones behind. Also, we use the state-of-the-art OSGi. And like I said, so you see a lot of them here. And like I said, forgot about it, but we use the feature launcher. What will be the feature launcher? And also we proposed last year to see how to have a WebSocket whiteboard specification, both for client and server, because that's something that appears necessary for the future developments for us. So why don't you use Sensinact yet? So like I said, when you start with Eclipse, you have at least that. So the Sensinact core, that's where the EMF magic happen. We also have the device factory core. So in fact, you describe your devices, the access to your devices and their properties via a JSON file. In just a description, you just say, I connect either an MQTT or an HTTP server, and what I receive will be parsed. So for example, it's CSV, it's JSON, it's XML, etc. And you say that that path in the XML, for example, corresponds to that property in my Sensinact model. So that's where, for example, having the weather here in mind should take mostly 10 lines of configuration in the MQTT device factory, and you will have it in Sensinact afterwards. You even choose your polling period, etc. So you can test every minute if the weather changes or not. And like we do at Kentu, you can create your own custom bridge and put your logo there for your own protocols. So I was faster than expected.
Way faster,
Yeah.
which is good. We planned for that.
Yeah. So you should join us. We don't have cookies. But yeah, so you can find the Eclipse Sensinact gateway source code on GitHub. It's obviously in the Eclipse license too. And we now have a Read the Docs website, so we now have a documentation somewhere. So, thank you.